This is CS 124, Lesson 2.5, Loop Design. By now you should already know how to write a while, do while, and for loop. Today's lecture will teach you how to use a loop to solve a complicated problem. There are three main ways to use a loop: count-controlled, event-controlled, and sentinel-controlled events. A count-controlled loop will execute a fixed number of times. Usually this number is known prior to executing the loop. For example, if I were trying to determine how many students completed the last homework assignment, I would count until I've reached the total number of students in the class. Inside of the loop, I determine if the student completed the assignment or not. These kind of problems usually require a for loop. For example, here's the pseudocode for our homework problem. Inside of the loop, we determine if the student completed the assignment or not. If they did complete the assignment, then we increment the total number of completed assignments. Count-controlled loops are also marked by the presence of a single variable that moves through a range of values. In our example, that would be the variable count. Count moves from 0 to 1 to 2 until we reach the total number of students in the class. However, this value does not have to increment by 1. It could increment by 2s or 10s or anything you need to solve your problem. This is a brief example of a counter-controlled loop. In our main, we simply explain what's going to happen before we call any functions. What's going to happen is we're going to prompt the user for a number, and then we're going to find the sum total of all the integers from 1 to the number they inputted. In order to get the number, we have a function called getNumber, which simply prompts the user for an integer number and then returns it to main. We then pass this into getSum, which is where our counter-controlled loop is. This for loop is counter-controlled because we are going to continue the for loop until we reach the number inputted by the user. We're going to increment by count, and count is going to start at 1. So if the user inputs 5 for the number, we will start with count at 1 and sum at 0. The first time through the loop, count is still less than number, so we add 1 to the total sum, so sum becomes 1. The next time through the loop, count becomes 2. Sum is still 1, so we add 1 to 2, and our total sum is 3. Then we go through, count is 3, we add 3 to 3, and our sum is 6. This continues until we reach 5. After we reach 5, the loop is terminated and we return sum to main where it is displayed. So we first got our prompt, what number would you like to use? We'll start by adding all the numbers from 1 to 5. Let's try it with a bigger number. Our total should be 5,050. An event-controlled loop continues to execute until a specific event occurs. A desired number may be reached, or maybe an error gets thrown. A good example of this is trying to get valid input from the user, since we won't continue until they've input a number that we like. Instead, we continue to loop until they put an input that meets our criteria. Event-controlled loops usually use a while or do-while loop. In this example, we want a GPA between 0 and 4.0, so we continue to prompt the user until they enter a valid GPA. If they enter a valid GPA the first time, they will only be prompted once. Here, I've turned our pseudocode into an actual program. We have our main that calls the function getGPA. In getGPA, we have a while loop that continues to prompt the user as long as what they input is greater than 4.0 or less than 0.0. Notice that the GPA has to be initialized to 5, otherwise the while loop will not fire. Let's try a negative GPA. Because that is less than 0.0, we're prompted again. If we try 6.3, that is greater than 4.0, so we get prompted again. When we input our actual GPA, the loop finishes and we return back to main, and our GPA is output again to us. Let's try this as a do-while loop. We move our while statement down here and add a semicolon to the end, and add the command do. If we do that, we can initialize our GPA to 0, and it will not affect how our program functions. Once again, we can try a negative GPA, a GPA that's too big, and then an actual GPA. In a sentinel-controlled loop, we use a variable to determine if the loop is going to continue looping or stop. The variable acts as a sentinel or gatekeeper for the loop. Usually, the Sentinel uses the while or do-while loops, where the Sentinel variable is a Boolean statement. In this example, play again is a Boolean variable. As long as the user enters a non-zero value, the loop continues. When the user puts in a 0 to stop playing, the variable play again is false, and so the loop terminates. This program is very similar to the example you're given in your book. In this case, our Sentinel variable is the Boolean variable past, which is initialized to false. As long as past is false, we will continue to execute our while loop. Under certain conditions, past can be changed to true, like if we got greater than a C in the class. First off, we're prompted for our grade. Let's say we got a 20 in the class, but we did not cheat. Because we got less than a C in the class, we did not pass the class, and so past remains false. Therefore, we have to go through the loop again. This time, let's say we got a 95 in the class, but we did cheat. Even though our grade is greater than 60, past is false because we cheated in the class. Now let's say we got an 85, we did not cheat. Because we got higher than a C, and we did not cheat, past was set to true, and so the loop ceased to execute. Now you should be able to understand how to apply loops for complicated problem solving. We will now have a brief quiz. There will only be 2 questions, and you will have about 5 seconds each. Remember, if you need to pause so that you can take a longer time to look at the question, feel free to. A count-controlled loop continues to iterate until when? A count-controlled loop continues to iterate until a specific number is reached. A sentinel is usually what kind of variable? A sentinel is usually a Boolean.